Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com, and I'm here for another session of Tuesday Math, where we go over everything math related for your teacher certification exams. So we're going to go ahead and get started here in just a second, but just want to welcome everybody that's joining us, and I'm glad you are joining me. It's the second week of August. It's getting close. Some of you are starting school. I know in our district, first day of school is tomorrow. Some of you are next week, later on in the week, but it's coming. So I'm going to make this a quick session so that you guys can get back to doing what you probably need to do to set up your lesson plans and get all that stuff ready for that big first week of school or the beginning of preschool week and all that good stuff. So for now, we're just going to go over math. And it's going to be just kind of a generic session like always. I've got 10 problems that encompass many different aspects of math, whether you're taking a low-level math, which would be like your elementary, all the way up to some high school math that you'll see on your exams. Mostly I keep it into the middle, more general. If you're taking like a Praxis Core type of test or a elementary education type of test, middle school math type of, kind of, I mean, that's kind of like everything. But regardless, that is what we are going to present to you tonight. We are live on our Facebook group, which is the Teacher Certification Exam Help, and also on our YouTube channel. And so I just want to make sure if you have any questions that you can go ahead and comment in the comment sections below on either one of those, whether it's Facebook or if it's YouTube, and I will get to those as best as I can. So I'm going to open up those windows now to make sure I've got the live feed going in case you do have any questions. And then we're going to go ahead and get started. Just like everything and every week I tell you, make sure you've got two things going. And the first one is going to be the calculator. Again, I don't know what test you're taking, but all the tests except for I think a couple allow you the use of a calculator. Look at your test specs, make sure you understand with the test that you're taking that you get to use a calculator and the appropriate calculator that you do get to use. Stop using your cell phone as a calculator because you're not going to be able to use it during the test, therefore you're not allowed to use it while you're studying. The second thing is the use of scratch paper and understanding and getting used to using scratch paper. You're taking these exams on a computer, therefore you don't have the ability to write on the screen like you would if the problem was right in front of you, like you do out of a workbook or printed paper. So if you do download the problems, you'll see the link in both the YouTube and the Facebook page. You'll see the link of the 10 problems, and each one is printed on its own slide. So it's got plenty of room underneath the problem that you can do your work on. And that was done purposefully so that you can practice working on scratch paper, because you need to learn how to see it on the screen and then transcribe it onto your paper, at least the information that you need necessary to solve. So with those two things said and done, we're going to go ahead and get started. And all right. So we have our first problem here. And this is an inequality problem, and they've got the graphs to show. So we're going to go ahead and just get started by solving the inequality. It says, which of the following options represents the solution set for the inequality? So we need to solve it, and then our answer is actually graphing it. So those are the two steps that are necessary in order to do this. So just like I was telling you about the scratch paper, if I were to do this, or if you printed this problem out, it was in a workbook, you would immediately probably start working underneath the problem like this. And then, doing all this kind of stuff underneath the problem, working it around. I know I'm just scribbling on there, but I'm just trying to make the point. You can't do that. You have to take what you need from the screen and then write it down. And this is a skill because it takes time. The less you write down, obviously, the less time it takes. So that's why you have to get into a nice rhythm of only using the information that you need and not necessarily solving everything step by step. So we need to go ahead and write it down. So I've got negative 4x. Going to give me a couple minutes here so I can get used to writing with the iPad. Okay, I've got negative 4x plus 1 is less than or equal to 21. So if I'm trying to show you all the tips and tricks that I can on this, right away, what I can do is go ahead and eliminate anything that I recognize can't be the answer. This right here, the sign is never going to change. When you get an inequality and you're given the sign doesn't change. And what I mean by that is this is a greater than or greater than or equal to. A greater than or equal to can't change to a greater than or a less than. See what I'm saying? It's got the equal to underneath it. Real quick, when we have a less than or greater than equal to's, then that means we have a fully complete circle. When we have a less than or greater than, that means we have an open circle. Because this cannot change, I'm going to have a closed circle. I can eliminate D and B right away. So things like that are what I'm trying to show you so that you can save time by eliminating answers, because now I've gone from 25% chance to 50-50. Okay. Next, let's go ahead and solve it. So the way we want to solve it is just like anything else. When you see an inequality, you solve it kind of treating it like an equation. So I want to subtract 1 from both sides, and I get negative 4x is greater than or equal to 20. Okay. Now I have to divide negative 4 in order to get x by itself. But here is the kicker. Whenever you divide by a negative number, you have to switch the sign. This will come up on exams, especially standardized exams, because this is the only time that this happens with inequalities. When you divide by a negative number, your inequality flips or switches to the opposite. Sorry, I can't get a good grip on that. That's just like that, whatever. So because I'm dividing by a negative, it's going to cancel out. It gives me x is now less than or equal to, and then 20 divided by negative 4 is going to be negative 5. Well, I know I'm going to get negative 5 because every single one of these was on negative 5. So that's a good way to check myself. The problem is which way is the sign going? And the sign is x is less than. So how do I graph that? When you're graphing inequalities, I find it best to actually say it out loud. This, as you say it, is x is less than or equal to negative 5. Well, if I'm at negative 5 on a number line, let's start with A. If I'm at negative 5 on a number line and I'm less than negative 5, it's going to be all of these numbers here. Well, to highlight that, you just darken that one to the left, and you'll see how it's darkened here. And so you'll see that A is the one that I want to choose. So that's the correct answer. If I look at C, I'm at negative 5. But again, don't get confused because, it's negative numbers. And 4, 3, 2, 1, 0, that's less than 5, but it's not less than negative 5. So just be careful on that. This is a two-part. That's why I picked this one. It flips the inequality, and then it also uses a negative, and they want less than of a negative, and it kind of tricks your brain. And I always tell my students, whenever you're dealing in negative land, everything is opposite, right? That means these bigger numbers, negative 6, 7, 8, 9, the bigger number, right, is actually smaller. Okay, so I hope that makes sense. Okay, problem number 2. A linear function, f of x, is used to generate the table shown. Which value is equal to f at -1? Given our chart here, we have x and then f at x. And then if we have f at -1, so what does all this mean? This is all, function notation. And so with function notation, it's just basically telling you, I have this, see how this says f at x, and then it's f at -1. It's telling you x is equal to -1. These are all the values of x that you have for this function, this particular function. There's an equation for this function. You can find out the equation using these values, but we don't need to do that. That's not necessary right now. We just need to understand that when x is -1, what is the f of x, or the y value? It's so much easier to just say x and y, and that's what these are. Left side of a chart is x, right side of a chart is y, and that's how we figure this out. So if I want -1, -1 is going to be up here, right? Because as I go 0, 1, 2, 3, I'm counting, I'm going up. -1 will be in the opposite direction. The goal is to figure out what essentially it's what the slope is, but what is the difference? So when I have x at 0, I have 4, x at 1, I have 13. What is the difference between these two? So if I do 13 minus 4, I get 9. If it's a function, a linear function, that's why they use the term linear function, then all slopes should be the same. That means the difference should be the same between the two. So that's a difference of 9. Well, if I go 13 to 22, 22 minus 13, again, that's going to give me 9. So you see the pattern here, 9. So these are all 9, 9, 9. Well, if I need to go in the opposite direction, instead of adding 9, I'm going to subtract 9 so I can get my next value, because I got to get from 0 to -1. So if I do 4 minus 9, that gives me -5. And so the correct answer is going to be -5, which is C. The biggest thing that I can stress to you when you come across problems like this, I'm going to clean this up just so you can make sense of it. Whenever you come to problems like this, where it talks about a function and it's a table, you're going to want to focus on these values here, because those are all your slope. The difference is the slope, and they're all supposed to be the same. When you focus on this part right here, sometimes like it goes 0, 1, and then 4, and then 6, and it skips between some. You've got to make up for that. And that's another way that they'll trick you. So make sure you understand and you practice these types of problems where they're just tables, because the table has all the information you need, not necessary to really find the equation of the line, and then go ahead and figure out what it is that they want you to find. Question is asking, which states is this test? These tests are for all states. So any state certification exam that you're taking for teaching, whether it's Praxis, which is the one that encompasses more states, or your local state tests. Okay. Next question. We have a bag contains a number of plastic discs that are either red, green, or blue. 1/4 of the discs are red and 2/3 of the discs are green. Which is a possible value for the number of discs in the bag that are either red or green? So this is an interesting type of problem, because it seems like you're going to be able to, I don't want to say solve it fairly easy, but it can go a couple of different ways. So I just want to make sure that we're all on the same track as to how to start a problem like this. So we've got 3 objects, and we'll represent it as red, green, and blue. and it tells you 1/4 of them are red. So I got 1/4, so I can represent it as 1/4 are red and 2/3 are green. So 2/3 are green. What's the possible value of number of discs in the bag that are either red or green? So I've got 1/4 and 2/3. You think, oh, can I just add those up? And I've got a fraction, but how in the world am I going to get an answer if all I've got is fractions? So that's another way of how we're going to figure this one out. Because I have 1/4 and 2/3, I need to get the whole bag. The whole bag is going to be 100%, right? And in terms of fractions, 100% would be the same number over itself. For example, if I did, let's just do 2/2. 2/2 is equal to 1. That's 100%. Well, in our case, we have 1/4 and 2/3. So it's just like saying, what is 1/4 plus 2/3 plus some number is equal to 1. Okay. Because we need to figure out how much the red and the green represent. So when we add these up, I notice that I can do a common denominator of 12, which means my 1 is equal to 12/12. Does that make sense? Any number over itself is 1. So 4 1/4 needs 3. So 3/12 plus, and then this needs a 4. So it's 8/12, and then plus, and this is where you can either do it in your head, or because this is some number here, add these together. I have 11/12 plus x equals 12/12. Well, you see, I got 11/12 and I need 12/12. Hopefully you can just do that in your head and understand that I just need one more to make it 12/12. Does that make sense? 11/12 and 1/12 are equal to 12/12. So I have 11/12 of the entire amount of discs in the bag. Does that make sense? Because we need to group red and green. This is blue. So I can just, this is red and green, and this is blue. It's asking me for how many are red or green. And here are my totals here. So let me show you how to get that. So you understand how I got the 11/12. If not, you can check it back on the replay. I'm just going to erase this so you can see my red, green, and blue. All right. So I have 11/12. 11 is red and green, or the number of red and green together, right? So it has to be in 11. And again, well, here, let me do this. Let me make it more sense. I'm sorry. In order for it to work out, I've got to have 11/12 is my ratio, and it's proportional. That's how we can get the number that we're looking for, where the top number is the red plus the green, and then the bottom number is the total amount of discs. Since it's asking the number of discs in the bag are red and green, and it's proportional, it means that this number here, my red and green, have to be so many times bigger or so many times smaller. Well, that's why we use a ratio. This is my red green number. This is the amount that it has to be so many times bigger or so many times smaller, which means it has to be a factor of 11. Does that make sense? So then out of all of these numbers here, which one will be divisible by 11? So you would take it, if you needed to, use your calculator, but I'm just going to show you 18 divided by 11. That doesn't work, right? So that equals, that doesn't work. And then 36 divided by 11, that equals, that doesn't work. 42 divided by 11, that equals, that doesn't work. 88 divided by 11, is equal to 8. I've got a whole number there. That means that that can be. Now, remember, this said possible. It didn't say how many are there. They did not give you enough information in the prompt. And that's what really bothers people is you're probably looking for the exact answer. Like, how can I tell if any of those can be the answer, right? No, it cannot, because these red greens have to be in this factor of 11 or multiple of 11. And the only way we get that is if one of the possibilities was 88. Okay, I hope that makes sense. So that's whenever they ask you something in this regard and you're using these fractions, specifically these ratios are always so many times bigger, so many times smaller. But the thing is, it's a multiple, which means you have to use a factor, and factoring just means kind of divide it. So take any of these numbers, the magic number to divide by is 11, because that's what we figured it out. And that's your answer. Okay. All right, moving right along. Okay, we have the steps for making a cube-shaped box by cutting and folding a rectangular piece of paper as shown in the diagram. If all the small squares shown in step 2 are congruent and the volume of the box produced in step 3 is 216 cubic units, what is the area of the rectangular sheet of paper in step number 1? Okay. So as you see, we took a paper, we cut it up into squares, and then we made what's called a net, right? A net is, in geometry terms, a two-dimensional representation of a three-dimensional object. When you fold it on all the dotted lines, you create a cube. So there are all different properties involved with cubes. One being all sides are the same, right? Because it's a square. In order for us to figure out any of these dimensions, it tells us it's 216 cubic units. So how do we find volume, right? It says volume, 216 cubic units. Volume is equal to length times width times height. Because it's a cube, it should be x times x times x, which is x to the third power, is equal to 216. How do I figure this out? How do I understand this? These are all the same exact number. So find a number that when multiplied by itself 3 times is 216. If you have a scientific calculator that does it, it's the same as saying, what is the cubed root of 216? That's how you write it kind of in math terms. If somebody understands that, great. If not, go with this first one here. So then, depending on the test that you have, pick a number. So if I had, let's just say 3. So 3, and you just start like that, and you just take your calculator and you go through it. So 3 times 3 times 3 is equal to 27. No, that's not going to work. 4 times 4 times 4 is equal to 64. Nope, that's not going to work. 5 times 5 times 5 is equal to 125. Not going to work. 6 times 6 times 6 is equal to 216. Oh, bingo, right there. So what does that mean? That means our dimension is going to be 6. Okay. So it's just trial and error at this point when you're fine. You know what to do, and you're just tapping on the calculator. Now, mind you, this is a test. It is a timed test. They just want to assess that you know this standard or this spec. So they usually don't go any higher than really 9. I mean, 9 is a big number, but in this case, 6 is about as high as you're going to go, because then you start getting these really large numbers. And that's not the point of this. They don't want you solving something where like 14 would be the dimension and you got something crazy going on. So we know that 6 is our dimension. So that means 6 right here, length, width, and height. So I'm going to erase this to make some more room. And now we just work backwards, volume. And now we need to figure out really what the question is asking. It said, what is the area of the rectangular sheet of paper? So I want the area here. Area is equal to length times width. So I need these dimensions, and I'm going to figure out these dimensions by using these blocks here. So we're going to try and make it real easy. Remember, we've got to use scratch paper. So all I'm going to do is, I see this is 1, 2, 3, 4. So I'll kind of make my own rectangle here and know that I've got 1, 2, 3. So I got 1, 2, 3, 4 right there. And then 1, 2, 3, there's 3 boxes. I'll go just like that. Okay. Each one of these is going to be 6. And then each one of these is going to be 6. So that when I go ahead and add them all up, 6 times 3 gives me 18. And 6 times 4 gives me 24. All right. We'll just say that. Now I just need to find the area. Area is length times width. So let me find some room. Area is equal to 18 times 24. 18 times 24, which gives me an area that is equal to, thought I had it on there. 18 times 24, 432. Boom. C is our answer. Okay. So that's it. It's just, a lot of these are logic problems. The math is not so difficult because they're not giving you crazy dimensions. They're just telling you it's a cube. So, oh, it's a cube. All sides of a cube are the same. And then you start breaking it down from there. Okay. And then the bigger thing was figuring out how many of each of these squares, what the dimension, where it's like 4 by 3 of these squares, each one is 6, and then go ahead and find your area. Okay. All right. This one's an interesting problem. I like this problem just because of the way that they got it set up. And you've got to make sure you understand how to read graphs. So based on the information shown in the graphs, which value is closest to the difference in miles per hour between the speeds of the two bikers? So I got to figure out what my miles per hour are. Seems pretty easy, but you have to understand this is in feet, this is in seconds, this is in miles, this is in hours. So I don't have to convert anything for biker B, but I do need to convert for biker A. And it's all a matter of how do you want to convert them. The way I'm going to do it, I'll show you my way. And if you like it, great. If not, then you can do it the regular way. Well, there's really no regular way, but there is a couple of ways of doing this. I'll start with biker B because that one's a little easier. And it says it in miles per hour. Miles per hour, so MPH is the same as miles divided by hours. So when we look at our graph for biker B, we have miles here, which is the y-axis. That's the y-axis. And hours here, which is the x-axis. They give you a specific point. It doesn't matter. Any point on this graph will give you the miles per hour because it's linear. So no matter where you get your coordinates, you're fine. The only one that you can get is the one that they give you. Don't try and figure out, oh, here's 100 and here's this one and that's equal. Don't do it because you're going to be wrong. They give you the coordinates, so the work is already done for you. Because it's miles per hour, that's why I did this here, miles over hours, okay? This is X and this is Y. Coordinates are always done X comma Y. I've got to do miles first, which is my Y coordinate. So I do 220 divided by my X coordinate, which is 10. And that gives me 22 miles per hour. Make sense? Easy, done. Okay. I need to figure out what the difference is between B and A. Here is my miles, or I'm sorry, here is my point. This time it's feet over seconds. So now what we're going to have to do is we're going to have to kind of figure this out and convert it. So same concept, I need feet over seconds because it's our distance over time. So I'll do 264. And in this case, I will do feet. Well, here, let's do this first. Yeah, 264 divided by 20, and this is seconds. And what I get is I get 13.2. Now, I bet if I did 22 minus 13.2, I get 8.8. See 8.8? They put that there. Some people will go ahead and choose that as the answer, and they'll get it wrong because this is feet per second. And so I need to convert this. So as long as you get this down to 13.2, I'm going to show you how to do the line conversion. So we got 13. I'm just going to take this because I need a little bit of room. So with the 13.2, 13.2 is feet over second. That's 13.2 feet for every 1 second. Okay. Because it's over it, that's where you do the 1. Now, what you have to do is you have to cancel out the feet and the seconds, and you have to do it with the conversions. And so to do that, I know that there are 5,280 feet for every 1 mile. And the reason why I did the feet on the bottom is because see how this is a division problem? I know it says multiply, but you're multiplying fractions. Fractions multiply across. If I took feet over feet, what does that do? Anything over itself cancels out. So that means the feet measurement will cancel out like that and leave me with the new one, which is miles. Next, I want to get rid of seconds. So I can either do this now and I'll get 13.2. Well, here, let's do this. If I do the math on the calculator, 13.2 divided by 5,280, I get 0.0025, and that's miles per second. I still need to convert those seconds. So I could take my 0.0025 miles per second and now get rid of the seconds. There are 60 seconds in 1 minute. Seconds will cancel. I don't need minutes, I need hours. So 60 minutes in 1 hour. Minutes gone. Now all I do is 0.0025 times, and multiplying fractions go straight across 60, which gives me 0.15 times 60 again, which gives me 9. So you have miles on the top, I have hours on the bottom. That's the same as saying miles per hour, and you've converted these two. Since I've got 22 here and 9 here, the whole point of this problem was to say, what is the difference between the two? And so after we convert them, we have, I'm just going to do it up here. 22 minus 9 gives me 13. C is the correct answer with 13. Okay. If you don't know how to convert using this way, which once you get it, it's real simple because all you're doing is putting your values, your conversions in the right spot. You know that you have to get rid of them in order to get the new one, like going from feet to miles. So I know I've got to kill each one of those. And the only way to do that is to have the same on top and the same on bottom. What I mean by that is the same unit, whether it's time or distance or measurement or anything to that effect. So I encourage you, if you need help on those conversions, get some more problems that will convert, in this case, seconds to hours. That's 2 conversions. That's probably the max that you'll ever have to do on a standardized test, unless you're doing an upper level math. But 2 is usually the most. So like from seconds to hours, that's 2 conversions, but feet to miles, that's a 1 conversion. That's what you'll see mostly on these types of tests. Okay. Problem 6. So for problem 6, I have a cylindrical fish tank, and it has a diameter of 24 centimeters and a height of 60 centimeters. If a certain small fish requires approximately 1,925 cubic centimeters of water per fish to thrive, what is the maximum number of this small fish that can thrive in the tank? So this is another geometry problem with a cylinder, and you will have formula sheets on your exams unless you're taking a high school level math. Then I think for the most part, you should know what the formulas are, but any other test, they're going to give you a formula sheet and you'll have access to what the formulas for different objects are. We've got a cylinder, which is like a can, okay? And it says we have a diameter of 24. Important to know what diameter means. Diameter is a point on a circle that goes through the center to another point on the circle. And in this case, it's 24. Our height is going to be 60. We need to allot 1,925 cubic centimeters for every fish. So what's the max that we can go? First thing, and the one that's going to trick a lot of people, well, first thing is volume of a cylinder is equal to pi r squared. That's area of the circle times the height. Radius is what we need to have. We have a diameter of 24. In order to find the radius, we have to divide by 2. So you've got to go 24 divided by 2, which equals 12. The radius is equal to 12. We can input everything into our equation. So just use 3.14 times 12 squared times our height of 60. And that gets you 3.14 times 144 times 60, which gives us the big number of 27,129. Ooh, running out of room. I'm sorry. I should have went a little further left. 27,129.6. So that is the volume of this cylinder. So what does that mean? That means we need to take said volume and divide it by 1925. 1925 represents each fish. So when we do that, we get 14.09. Now this one comes out fairly easy because it's 14.09. Now you need this much water for every fish. We've got 14.09. This means that we round down. There's not enough to put 15 fish in this tank because you're not going to have enough water. Usually when we deal with whole objects, like if it asks for how many tiles would it take to tile this fish tank, whatever, and I got 14.09, then the answer would be 15. You would always round up when you have physical objects. In this case, we need to have whole numbers in order to provide for, in this case, the fish. So we always round down to the nearest whole number. Well, we just always round down to the whole number. So in this case, I need 14, and A is going to be the correct answer there. Okay. This fish tank can, based on the specs of 1925 cubic centimeters of water, it can only sustain 14 fish and nothing more. Okay. Basically, you're just finding the volume, and be careful about diameter because that gives you diameter and you need to find radius. Okay. Let me just double check and make sure I've got everybody okay on our Facebook. Give me a quick intermission here for a minute. Okay. Looking good. Okay. No questions. All right. Let's take it to the home stretch. All right. Question number 7. All right, this one might be a little more advanced, but they throw this in on some general knowledge type of tests, just because it is in algebra. But the biggest thing is, and don't let it fool you, is this I. I stands for imaginary number. We'll get into it as soon as we start doing our math. Just says, which of the following is equivalent to the product? And what we have here is a multiplication problem. So we need to rewrite it because remember, we can't do anything on the computer screen. So I've got 3 plus 2i and then 4 plus 3i. And all we do is just distribute. So I'm going to start with the first number, which is 3. So I'm going to go 3 times 4, which is 12, and 3 times 3i. Treat the I as a variable. So we're not doing anything to it yet. And it's just like saying 3x or 3a or 3y. It's just 3i. So 3 times 3 is 9. And then our I hangs on there. So that's good. We're done with 3. Next, we go with the 2. So 2i and 4 give me 8i. And then 2i and 3i give me 6 because 2 times 3 is 6. But I times I, or any variable multiplied by itself, is now going to be that variable squared. Next, do everything else that you normally would. You always combine like terms. I see that I have 9i and 8i. I squared, remember, is not the same as regular I. So I have 12 plus, and 9 plus 8 is equal to 17. So 17 i's here plus 6i squared. Now, here's the only thing you need to know if you ever get a problem like this, and it's just real simple. If you ever get I squared, and it's this kind of I here, that italicized I, it equals -1. Okay, boom, just like that. Anytime you ever see an I squared, it's equal to -1. Because of that, I can substitute this -1 into here. So now this becomes 6 times -1. So that's no longer that anymore. And then I have 12. I'm gonna write this over here. I didn't realize I was going to do that big arrow. I now have 12 plus 17i minus 6, right? Or -6 plus -6, but 6 times -1 is -6. Now I can combine 12 and -6 to give me 6 plus 17i. That is as far as I can go with this problem. I can't do anything else because I is itself, it's an imaginary number. And so you'll notice that A matches exactly what I need, 6 plus 17i. Okay. I'm not gonna go any crazier, right? I squared or I imaginary number, just it represents a negative square root, but I'm not going to get into that because that'll confuse you even more. So if you ever see I squared means -1, and then just substitute that I squared for -1 and go ahead and continue the problem. Okay. Just math after that. Okay. Problem number 8. In the diagram above, line 1 is parallel to line 2. If the measure of angle B is 100 degrees, what is the measure of angle E? Because these are parallel, so real quick, this is parallel to this line right here. Why we have, when we have a line that goes through two parallel lines, it's called a transversal. That means that wherever those lines intersect, in this case, we have this intersection point here and this intersection point here, angles correlate to each other. And so that means that if I were to take this intersection and put it right on top of this intersection, they would all be the same. Case in point, the top left is the same as the top left. So A is the same as E, B is the same as F, C is the same as G, D is the same as H. Okay. Now I have 100 degrees as angle B. So if this is 100 degrees, then it correlates to angle F, which is also 100 degrees. So by definition, if I need to find angle E and these are on the same line, we know that two angles on a straight line are known as a linear pair, which means it's equal to 180 degrees. So if I have 180 degrees that I need and I take away 100, I'm left with 80 degrees. That means angle E is equal to 80 degrees, which is my answer. Okay. That one was pretty simple as long as you know how to work it. They'll give you anything in this top. So they can give you the values of A, B, C, or D, and you can correlate it to any of the angles in the next intersection. And if there were another line here that's parallel to those lines, then this would be, this intersection here would be the same exact thing, right? These will be the same as these, which are the same as these. That's just how it works. Okay. All right. Question, why x to the third for the volume length times length width? Oh, okay, that must have been a while ago. X to the third for volume length times width times height. Yeah, so milligross, y x to the third for the volume length times width, because the volume, if you're talking about that cube problem, they're all the same. So length times width times height, x times x times x, x to the third. Okay. Okay, problem 9. Which of the following is a prime factorization of 900? Just a good opportunity to do prime factorization. And you can always do these in a number of ways. So we start with 900, our number, as our factor tree, and just use as simple a numbers as possible, just to make it easier so you can do the math either in your head or quickly in your calculator. I know that I can take 9 and 100. That's pretty easy to do. And then I can break it down from there. 9 is the same as 3 and 3, and then we're done. 3 is a prime number, and we've got 2 3s in our number. So because it's 2 3s, if I look at my my answer choices, 4, 9, and 25 are not prime factorizations, right? Why are they not prime factorizations? Because 4 is not a prime number, and 25 is not a prime number, and 9 isn't even a prime number. So it can't be that. Can't be 16, 5, and 11, because I know that I need 2 3s, so that's gone. I see I've got 3 3s here. That's not going to work. Oh, wait a second. I should hold off on that. I'm sorry. I should hold off on that. Just because knowing the other number, I can see it already, but we'll just hold off for now there. Like I would have picked C because I'm sorry, not C, D, because that's the only one with 2 3s, but you never know. You got to understand what the font, and I can look at 100 and I can say there's no more 3s in 100. So anyway, if you see that, then yeah, go ahead, answer the question and you're done and you solve it in like a couple seconds. But let's just continue our factorization. That with 100. So with 100, I know that I can do 5 because that's a prime number, and then 20, and I'm done with the 5 here. When I go down with the 20, I know I can do 5 again, and then this is 4, and then break the 4 down into 2 and 2. Now I see that I have 2s, 3s, and 5s. I have 2 2s, I have 2 3s, and I have 2 5s, and that's going to get me D as my answer. Okay, so just quickly with the factoring, don't make it harder than it needs to be. Use your calculator if you have to. Don't be ashamed. I have a lot of people that just don't pick up the calculator. You should have that calculator in your hand pretty much the entire test because you should be using it. Don't be afraid to use the calculator, okay? All right, and then the last one, I've got an equilateral triangle, has a perimeter of 24 centimeters. If the triangle is dilated by a factor of 1.5, what is the perimeter of the new triangle? Okay, interesting. What is, and again, a lot of these problems, and especially the word problems, go back to, do you understand the terms, the math terms that they're throwing at you? An equilateral triangle, by definition, has all sides the same. So if I make a triangle that's all sides the same, pretend that's all sides the same, and my perimeter is equal to 24, we need to understand what perimeter is. Perimeter means add all sides. Well, all of these sides are exactly the same. So, I mean, technically, if I'm doing this, if I do x plus x plus x is equal to 24, I have 3x is equal to 24. You wouldn't be doing this. I'm writing out the thought process, but you should know that, okay, I've got 3x's, x of the sides. I have 3x's. This is what it looks like. Then I divide by 3 and I get x is equal to 8. And so with a side value of 8, okay, I'm going to go ahead and use that for my dimension because the equilateral is 8, 8, 8, 8. I have a triangle that is dilated. Now, this can be a confusing term because, uh-oh, did I do something wrong on the last one? No, angle E. No, the problem said angle E, not angle H. Sorry, it just popped up on the Facebook. Somebody asked that. Okay, back to this. So dilated. Dilated just means you're going to think of your eye. What happens when your eye dilates? It opens up bigger or it contracts and goes smaller. Well, with a factor of 1.5, 1, and we'll call it like this, 1 as 100% stays the same. If it goes 1.5, 150%, that, so like this is 100%, that's your normal. 150 bigger. If it were less, let's say it was like 0.5, which is like 50%, then smaller. So a dilation can be bigger or smaller based on the scale factor. If it's bigger than 1, it goes bigger. If it's less than 1, it goes smaller. So just want to give you kind of a visual on that one. But either way, if it's dilating at a scale factor of 1.5, that means I have a triangle that is an equilateral triangle, and it's bigger than this triangle by 1.5. So I take my side value and I just multiply it by 1.5, right? That would be a scale factor of 1.5. So 8 times 1.5 gives me 12. So I have 12, 12, and 12 as my new values, right? Because equilateral all are the same. When we do, because we need perimeter, so we need to add all the sides together or do 12 times 3, we get 36, and C is the correct answer. Okay. So here's the kicker for this one. That's the correct way to do it. I don't know in any other way that they would make up this problem, but if it's something different than an equilateral triangle, this isn't going to work. But because I noticed it's an equilateral triangle, all sides are the same, everything is the same, and we're bumping it up by a certain scale factor, I could just say, what's interesting about equilaterals, and in this case, this problem, if I know that the perimeter is 24 and everything's going to be the same, well then, and I need perimeter anyway, right? Because it's asking for the perimeters. They're equilateral, they're all the same, and then the perimeters. If I know that my perimeter is 24 and I dilate everything by 1.5, well, it just so happens that, and that's why this works just for the equilaterals, right? 24 and 1.5 give me 36, which is also the same answer. So recognizing that will make this problem go quicker, but doing it the other way will help you out, just because it'll help you understand, how do I figure out the dimensions of these by dividing 24 by 3 and then bumping up my scale factor. Okay, question. For probability, why you add? Okay, that's I'll hold up on that one. So that's it for that one. That's the end of the 10 questions. Answers are always on the last slide for you. Okay. And let me just get to this question for the probability. So let's back it up. Okay, back it up to problem 3. There's a question for the probability. Why do you add for red and green and blue for X? Because it is unknown. Yeah, so if we were to back this train up on problem 3 real quick. Because we need to figure out what our scale is going to be. We were given 1/4, right? We always have to have 100% or same number over same number, 1/4 and 2/3, and then some number over some number and equal it to 1. So plus some factor here. And why do you add? We need to add for red and green because it says the discs are red and green. So how many discs are red and green in the bag? So that's why we need to figure out this, and these numbers need to funnel down into that 11/12, right? Because now I'm solely focused on this number here. I know that the entire bag is going to be in multiples of 12, but that's red, blue, and green. I know that red and green are always going to be in multiples of 11. So that's why I did that. Okay. Looks like back to number 10. We've got, can we dilate? You can dilate anything. Anything can be dilated. Dilated is a term that just means you're making it bigger or smaller by a certain scale factor. That's all it means. Okay. You'll see rotated. Rotated means you're turning it, and then reflecting it means you're going on the other side of an axis, but we don't need to talk about that. But yes, you can dilate anything. I can, if I have a rectangle here and then a scale factor of 2, well, then I just have a bigger rectangle. So if it's a scale factor of 2 times 2 is 4. So that would be 4. Okay. It's all the same. Yeah. If you have questions, then go ahead and email me if it's last week's session for sure. Okay. Other than that, that's it for tonight. If you guys have any questions, that is definitely not an N. If you have any questions for me whatsoever, info@KathleenJasper.com. Sorry for the scribble, but if you're watching me live or you're on the YouTube, you can find the email anywhere on there. And send me your problems, send me your questions, let me know what you need help with. And that's what I'm here for. So that's going to be it for tonight. This 1 hour flies every single time, even if I try to get it in quick. But I hope I was able to help you all out. Again, if you need anything, go to our website, KathleenJasper.com. Hit us up, info@KathleenJasper.com. Check out our YouTube channel. Lots of videos, lots of good information. And I wish all of you the best in these upcoming weeks as we go ahead and start a new school year that is going to try and be as normal as it has been since the past 3 years have gone by. So with that being said, thank you all for joining me, and I will see you